Water, the most abundant and versatile substance on Earth. Hello, I'm Mr. Fixit from ES Repair. Now, water is transparent, it's odorless, tasteless, and it's nearly colorless, and it's vital for all forms of life. Water covers 71% of the Earth's surface. It's seas, oceans, lakes, ponds. Now, you have, by volume, it's about 96.5%. Groundwater makes up about 1.7%. Glaciers in Antarctica and Greenland, that's about another 1.7%. While water and ice, that's suspended in the air, that makes up a small fraction. It's like 1,000th of a percent. So as you can see, it is a pretty small number. Now, water is used by agricultural. They use approximately 70% of the fresh water for irrigation, crop production, livestock feeding. Industrial uses 20% of the water to create electricity, suspend solids in slurries, dissolve dissolve and extract substances. They even dissolve chemicals for mining, chemical pulping to make paper, dyeing, printing, etc. Now, the average household uses 300 gallons of water per day. It's for drinking, cooking, cleaning, bathing, and sanitation. Fire departments, oftentimes they have to use water to extinguish fires. Now, clean water is essential for medical procedures, sterilization, and maintaining hygiene and sanitation in healthcare facilities. What about bodies of water? Well, it's used for recreational activities, swimming, fishing, boating. It even contributes to the landscape beauty, and it also has economic and aesthetic value. Now, water supports the ecosystem and wildlife, maintaining the balance of natural habitats and biodiversity. The human body is roughly 60 to 70% water. Now, water is critical to support life, yet it doesn't provide any food energy or any kind of organic micronutrients. Water is a universal solvent. Now, this is due to its properties. It can dissolve more minerals and gases than any other liquid. Now, this makes it an excellent use of water in living organisms. It can transport nutrients to and then also remove the waste from the cells. Now, with the addition of salt dissolved in the water, it also provides electrical conductivity, transmitting signals throughout the organism. I mean, water is everywhere, and no matter where you look, there is some form of water. Now, what makes it interesting is water is the only substance that can coexist as a liquid, a solid, and a vapor. Now, this is due to the Earth's unique environment being relatively close to the water's triple point. And this is the temperature at which temperature and pressure of sublimation, fusion, and vaporization curves meet. Now, for an example, you have clouds in the sky. Now, they consist of water vapors, which is a gas, that turns into precipitation that is in the form of rain, a liquid, or you have ice, which is sleet, and that's a solid. Now, when it's finally divided, crystalline ice may precipitate in the form of snow. Now, let's talk about fog. Fog's like a cloud, except it's more closer to the ground or the surface. Now, it is a visible aerosol consisting of tiny water droplets or ice that's suspended in the air. Now, fog is formed when the air temperature is within 2.5 degrees Celsius or 4.5 degrees Fahrenheit of the dew point. Now, the dew point is the temperature at which the air is saturated with water vapor. Localized fog that occurs near a water source, such as a pond or a lake, where the water is warmer than the air. Now, since water does absorb heat, as the air cools, you can see the water vapors emanating above the water. It's like steam from hot water. Now, the most fascinating fact about water that I find interesting is it's created by combining hydrogen and oxygen. Now think about it. The chemical representation of water is H2O. You have two hydrogen atoms to one oxygen atom. Now, hydrogen is represented as H2. It's known as a diatomic molecule. Now, each hydrogen molecule has a pair of hydrogen atoms. Hydrogen gas is colorless, it's odorless, non-toxic, and it doesn't react very well with other elements and compounds. But it is highly combustible. It's a major source of fuel. Now, hydrogen forms an explosive mixture with air ranging from 4% to 74% concentrations. Oxygen gas, on the other hand, is not flammable, but it is highly reactive. Oxygen is another diatomic molecule represented as O2. Now, oxygen is known as an oxidizer because of its high reactivity with other elements and compounds. Take rust for an example. Rust is a result of oxygen and moisture, which is the catalyst, reacting to the metal. Oxygen absorbs electrons to create oxides. So in this case, we're talking about iron oxide. Now, even though oxygen does not burn on its own, it does help other substances ignite and burn more intensely. This is why oxygen tanks must be kept away from open flames. It will cause fires to burn hotter and faster. Now, my question is, if hydrogen is highly flammable and oxygen supports combustion, then how does water not combust? I mean, you've got a flammable, you got an oxidizer. I mean, why wouldn't it burn? Well, that's where things get very interesting. Combustion requires three things: heat, fuel, and an oxidizer. Now, we already have hydrogen, which is the fuel. We have oxygen, which is an oxidizer. So the only thing we're missing is heat. Now, unlike some chemicals and gases that react to one another in close proximity when they're mixed, hydrogen and oxygen will not interact. Not even at room temperature, they won't react. Now, to get them to react, we need heat to create a synthesis reaction. Hydrogen will self-ignite at 500 degrees Celsius or 932 degrees Fahrenheit. Now, this can be achieved with just a spark or a flame. The heat breaks down the bonds holding the hydrogen atoms together and the oxygen atoms together. Now, with the bonds broken, the oxygen atoms, being the oxidizer, can now react with the hydrogen atoms. This process is highly exothermic, releasing enormous amounts of energy in the forms of heat and light, typically generating 142 megajoules of energy per kilogram. Now, each oxygen atom will bond with two hydrogen atoms, creating water with new properties. Now, keep in mind, this process converted two gases into a liquid. Now, since water is the product of the oxidation of hydrogen, no further reaction can occur, creating a stable compound. However, if you send an electrical current through water, it will split the hydrogen-oxygen bond, thus returning hydrogen and oxygen into their natural state, gas. Now, water does have a unique properties with the combination of hydrogen and oxygen. Water molecules stick to each other, which is known as cohesion, and to other surfaces known as adhesion. Now, this is why water forms droplets and can travel up plant roots and stems through capillary action. Water can also absorb a lot of heat before it begins to get hot. This property helps regulate temperature in the environment and in living organisms. This property is why sweating cools us down, as the evaporation of sweat removes heat from our body. Now, unlike most substances, water expands and becomes less dense when it freezes. This is why ice floats on water, providing an insulating layer that protects aquatic life in cold environments. Now, water also has a high surface tension due to the hydrogen bonds between its molecules. This allows small insects to walk on water and causes water to form droplets. Now, for a moment, let's go back to the fire departments, using water to fight fires. Now, it does seem counterintuitive that water can extinguish a fire, since, water does consist of hydrogen and oxygen. So, yeah, my question was, why can it combust? Now, because it cannot combust, it does have new chemical properties. And these are key properties when fighting fires. Now, for a standard fire, putting water on the fire absorbs the heat from the flames and the surrounding area, lowering the fire's intensity. After absorbing the heat, the water turns into steam, further cooling the fire. Now, with water's cohesion and adhesion properties, it can also act as a barrier between the fire and oxygen. Now, without oxygen, the fire cannot burn. So, as you can see, water is the most abundant and versatile substance on Earth. It's produced by combining hydrogen and oxygen through a synthesis reaction. Rust is the oxidized form of iron, and water is the oxidized form of hydrogen. Therefore, water can no longer undergo oxidation, since it is now a stable compound. Now, as a final note, it takes 0.93 pounds of hydrogen and 7.42 pounds of oxygen to create 1 gallon or 3.79 liters of water. And it's been estimated that there are 365 quintillion gallons of water on Earth. That's 365 million trillion gallons of water. That's a lot of hydrogen and oxygen in storage. You do the math. Well, that concludes this video. I hope it was informative for you. Please sure to click on the like button to show your support for the channel and the video. Don't forget to click on that subscribe button. And be sure to click on that notification bell so you're notified whenever I upload a video. Well, I'm your host, Mr. Fix-It. Thank you for watching.